everyone. Given f of x is mapped from the domain r squared, which remember, this means r, this is your Cartesian product. So that's what this means here. This is your domain, and this is your range. And that's what it's mapping to. So here is our f of xy for our Cartesian product. And we're going to answer these 4 questions. So for the first one, we're going to calculate f of 1 comma 2. So f of 1 comma 2 equals 2 times 1 plus 3 times 2, 4 times 1 minus 2. So this is going to give you 2 plus 6 is 8, and 4 minus 2 is 2. So that's all you have to do for that. Now for calculating AB such that f of AB is 12 comma 10, what we're going to do is write it out. Instead of x and y, we're going to write 2a plus 3b, 3b equals your x portion, and 4a minus 10 equals your y. And for the, well, we're just going to put b here, sorry. B equals 10. So basically, we got to solve for a and b. So we have a system of linear equations. And the first thing I can do is say, let's solve for b. So I multiply this through by 2, and we get 4a plus 6b equals 24. Copy down your second one and subtract. So if you subtract, you're going to get 7b equals 14. So b equals 2. Now to calculate a, I'm just going to multiply this equation by 3. So I'm going to write my 2a plus 3b equals 12. And then multiply this whole thing through by 3. Because that will eliminate the b. So you get 12a minus 3b equals 30. And I'm just going to add. So you get 14a equals 42. So a equals 3. So your answer would be 3, comma 2. All right, and for the next part, we're going to find the inverse. And how you do that is you let f of AB equals some PQ. And this is standard for the Cartesian product. So basically, let's plug the A and B in. So you get 2A plus 3B. Remember, this is your X portion, or your A portion, is going to equal P. And then your 4A minus B equals your Q. And then we basically do the same thing. Multiply the numerator by 2, or you could do negative 2 if it made it easier, but multiply that by 2, you get 4A plus 6B equals 3 or 2P. And then you have 4A minus B equals Q. So what you get when you subtract both of these, you're going to get 7B equals 2P minus Q. So your B is going to be 2P minus Q divided by 7. Now do the same thing to solve for A. We're going to eliminate the B, so I'm going to write my 2A plus 3B equals P. Multiply this equation by 3, so that gives you 12A minus 3B equals 3Q. And just add these up, and you get 14A equals, these will cancel, so P plus 3Q. So A is P plus 3Q divided by 14. So basically your answer is going to be, your A goes with this part. So that's going to be P plus 3Q divided by 14. And then this one is the B part is 2P minus Q divided by 7. But you can't leave it like that. So you need to use X's. So do you see where we have the B part goes with your X and the A part goes with your Y? We got to convert it back to X's. So I'm going to just erase this because we're running out of room. So you're just going to write your A part as X plus 3Y divided by 14. And your B part is 2X minus Y divided by 7. And that equals your inverse. All right. Now we're going to show that f of xy is a bijection. So for that one, what we're going to do is, first we have to show that it's injective and surjective. So to let it be injective, what you do is you do f of, we're going to let f of AB equal f of CD. And this is standard way to do it when you're doing the Cartesian product. So basically what we're going to have is 2A plus 3B and then 4A minus B equals, and then you write it again but with C and D. So 2C plus 3D, comma, 4C minus D. Now, we're going to set our x's equal, so we have 2A plus 3B equals 2C plus 3D. We also have 4A minus B equals 4C minus D. Now, what I'm going to do is go ahead and multiply this second equation by 3. So we're going to have 2A plus 3B equals 2C plus 3D. And our second equation is going to end up being 12A minus 3B equals 12C minus 3D. So what you end up getting is, you add this up, you get 14A equals 14C. Therefore, A equals C, which is the definition of injection. So when you have f of A equals f of B, then A equals B. So that's why we set it up like that. All right. Now substituting back in, we get, if you substitute it back into the equation, you also get B equals D. Hence, we have A, comma B equals C, comma D. So that's going from here to there. All right. So this means it's, therefore, it's an injection. All right. Now, we have to prove surjection. So for that one, we're going to note that every element Mn, and we're just picking some Mn, in the codomain corresponds. Remember, we already did the inverse. So our inverse was x's and y's, but if you let m and n be it, we have m plus 3n divided by 14. Remember the inverse we did. So basically, every element here in the codomain corresponds to this in the domain. Hence, f of xy is surjective. And then to show that it's a bijection, you just say, well, it's injective. So we'll just put injection plus surjection. If it's both, which it is, then it's a bijection. And that's it. Thank you. Have a nice day. Bye-bye.